and welcome to CEC live lectures. We have been discussing about different protocols which are working at the different layers of the TCP/IP protocol suite, and in the last lecture we had discussed about the TCP protocol or the transmission control protocol, which is basically a connection oriented protocol working at the transport layer of the TCP/IP model. The other protocol which is used in the transport layer at the transport layer is the UDP protocol or the user datagram protocol. Now the user datagram protocol is a connectionless protocol, right. So therefore in this also the communication starts without creating any logical connection. Okay. So the datagram in the UDP is also an independent entity, and there is no relation between the two datagrams which are being sent. So in a way, what we are trying to say is that there is no need for connection oriented services like error control and congestion control and flow control, because every packet is independent of the other packet which is being sent. So this protocol is a connectionless protocol, and it's a simple protocol because it does not use these services, as I've already said, and its simplicity basically means that it's small overhead and it's attractive for an application program which sends short messages, and there is no need for retransmission of packets involved. Even if a packet is corrupt or it is lost, then there is no need to retransmit the packet, because the packets are anyways, the messages are very short which are being transmitted, which are being shared through the UDP protocol. There is another protocol which is being designed for different emerging multimedia applications, which is called the stream control transmission protocol. So this is also a very responsive protocol for the emerging trends in internet, especially the multimedia, etc. Right. Now the next layer of the protocol suite, or the highest layer of the protocol suite, is the application layer. Right. So the application layer, basically there is again a logical connection is between end to end, right, and the two application layers, they exchange messages between each other as though there was a bridge between the two layers, right. So it, of course, we know that communication is done through all the layers, okay, but it appears as if there is a direct link between the two layers. Say for example, when we are sending an email to somebody, so we see that the moment we send the email and it is received, so it's almost like there is no conversion which has taken place, but of course the message has to pass through all the layers like the transport, the network, the data link and the physical layer, then only, and again the same same route is to be adopted at the destination also, and then the packet or then the data is sent to the application layer. So communication at the application layer is basically between two programs, right. Application word itself means program. So here the communication is happening between the two processes which are working, right, and for communication the process will send a request to the other process and it will receive a response. So process to process communication is the duty of application layer. The application layer in the internet, it has got various protocols, because there are different types of services which are, with different types of processes which are being used at this level. So the first important and the most popular protocol is the HTTP protocol, which is, a vehicle for accessing the World Wide Web. Then we have the simple mail transfer protocol, which is the main protocol involved in emails and services. Then we have the FTP protocol, which is used for transferring files from one host to the other. So uploading and downloading of files which is occurring is done using the file transfer protocol. Then for remote login or for telnet, we have the terminal network or the telnet protocol is there. Then we have the SNMP protocol, which is used to manage the internet at global and local levels by the network administrator. So likewise, there are multiple protocols which are used at the application layer. There is another very important protocol, which is the domain name, the DNS protocol, which is used by other protocols to find the network layer address of a computer, right. So network layer address of a computer means that it is the IP address that we are wanting, right. So we've discussed what domain name system is. So matching IP address for any domain name can be looked at using the DNS protocol, and then IGMP protocol is there, which is used to collect membership in a group, because we have Usenet, we have news groups, so different groups are there, so IGMP protocol can be used. So there is a whole range of protocols which are working at this application level. Now we after we have discussed the TCP/IP model in detail, we also need to look at a general model. Basically TCP/IP is not a model, it's a protocol suite, right. But when we look at the OSI model, so OSI is not a protocol suite, but it is a model, right. So OSI model was actually introduced by the International Organization for Standardization, that is the ISO, which is as we all know, the ISO standards are there. So ISO is a multinational body which is dedicated to worldwide agreement on international standards, right. And a large part of the world is a part, and they are represented in the ISO. So ISO standards, they cover all aspects of computer networking, and one of this is the Open Systems Interconnection model, or the OSI model. So this model basically was first introduced in the late 1970s, right. So we must keep in mind that the TCP/IP protocol suite has been in use much before the OSI model came. So the model has been introduced after the TCP/IP protocol suite was in use. So open system is a set of protocols basically which will allow two computers or two different systems to communicate regardless of underlying architecture, right. So basically its purpose is to facilitate communication between different systems without requiring changes to the logic of underlying hardware or software. So therefore this name Open Systems is given because it is going to be free of system architecture, free of hardware configuration, free of software composition of the system. So as I already said that it is not a protocol, but it is a model, and using this model we can understand and we can design a network architecture, right. So this model it aims at having network architectures which will be more robust, which will be very flexible, and that will be highly interoperable, right. And in this OSI model actually 7 layers have been proposed, right. So in TCP/IP we saw that there were 5 layers, but OSI model has got 7 layers, and each of these layers it defines a part of the process of moving information across a network, right. So if you look at this, the OSI model has got these 7 layers, and each in this of course we see that 2 layers have been added here, right. That is the session layer and the transport layer, right. So the session layer and the presentation layer are the 2 layers which are additional in case of OSI model, whereas in case of TCP model all the protocols which are related to the session and presentation layer, the functionality which the session and presentation layer offers, that is incorporated in the application layer protocols only. So therefore OSI is a 7 layered structure, TCP is a 5 layered structure. So first TCP/IP has more than one transport layer, right. So some of the functionalities of the session layer are available in some of the transport layer protocol, right. Second, the application layer is not only one piece of software, but many applications can be developed at this layer. So if some of the functionalities mentioned in the session and presentation layers are needed for a particular application, then they can be included in the development of that piece of software. So this is the rationale behind having these 2 additional layers in this. Now even though the OSI model looks very promising and it encourages further modularity than the TCP protocol by introducing functionality of session control and presentation, even then it has not found its place really in the time, and a lot of money and time has already been spent, you know, on TCP/IP suite. It's already, you know, in place, and it is being used very widely, and therefore large number of organizations, you know, they really did not want to move to the OSI model. So therefore the OSI model, you know, it became less successful because of this reason, and also because, you know, some layers in the OSI model, right, like presentation and session layer, which are added, they, you know, their protocols were never listed, they were never defined properly, right. So therefore, you know, you add something new, but then it did not you know, fulfill the purpose of, you know, it, because there were no specific protocols which were defined. So therefore corresponding softwares were also not fully developed. So because of, you know, these reasons, the OSI model, it could not, you know, really stand the test of time. It has not become as popular, and still, you know, TCP/IP protocol suite, it is sort of, you know, leading this scenario. Another important reason why the OSI, you know, was done was that it was implemented by an organization in a different application, and it did not show a high enough level of performance, so that, you know, the Internet Authority should have switched from TCP/IP to OSI model. So the performance front also, it did not, you know, prove it. So therefore, because of all these things, OSI did not work very well. So, you know, we have looked at how the protocol layering is created. We have seen how, you know, in the TCP/IP, what are the functions of the different layers, particularly, you know, the network layer, where we have also talked about a particular function of the network layer, that it defines, you know, it gives a unique address to all the hosts on the, which are connected to the internet, and that address basically is known as the IP address. IP stands for Internet Protocol and Address. Now Internet Protocol Address is basically like, you know, a unique identifier which is used, and this addresses, nowadays we see that instead of just writing IP address, we also, you know, suffix it with IP version 4 or IP version 6. So we'll see that what is basically, what is IP address, and what is IP version 4 address, and what is IP version 6 address. So IPv4 and IPv6. So identifier, basically the IPv4 is the identifier which is used in the IP layer of the TCP/IP protocol suite, of the network layer basically, and this actually identifies a connection of each device to the internet, right. So therefore this can also be known as the internet address. So it's very important to note that the IP address is not the address of a host, but it is the address of a connection. Okay. So IPv4 address is basically, it has 32-bit address, and it uniquely and universally defines connection of a host or a router to the internet. So every computer or every device, when it is connected to the internet, it needs to have its unique IP address, right. So it is, as I already said, you know, that this is the address of a connection. So therefore, you know, if one device has got two connections to the internet, so then it will have two IP addresses, because it is having two connections. Okay. When you talk about the host address, that is the physical address or the MAC address that we are talking about, right. But when we are talking about the IP address, we are only looking at the address of the connection. Okay. So therefore this is very important. The same device can have different IP addresses, right. So when you, for example, when you are carrying your you know, your phone from one network to the other, say you are moving from your educational institution to your home, so where both, you know, both have got internet connectivity, so you connect, when you are in your college, you connect to the internet, it has one IP address. When you go home, it automatically takes another IP address. So this means that IP addresses will keep on changing. When you change your network, your IP address will change. So therefore this is very important to understand that IP address is the address of a connection and not of a host, right. So they are universal because, you know, they are accepted by any host that wants to be connected to the internet, right. Now it is, it defines the addresses in an address space basically. Now what is an address space? It is the total number of addresses which are used by the protocol. So if a protocol, it has got b bits, b is the number of bits, okay, to define an address. So then the address space will be 2 raised to the power b, because b bit here is 0 or 1. So we are saying that, IP uses 32-bit address, right. IPv4 has 32-bit address. So it means that 2 raised to the power 32 will be something close to 4 billion addresses are there. Now when you have 4 billion addresses, now there is a constant fear that, there will be a problem of address depletion. Address depletion means that after a point in time, there will be no unique addresses left, right, because all the 4 billion addresses will be taken with, the number of internet users growing exponentially each day. So it's very likely that in a few years from now, IP addresses will not be there. So to solve this problem of address depletion, because of, this limited number of addresses that we have, another IP address format has been suggested. It is already being used, which is known as the IP version 6 address, right. So the main reason why we need to migrate from IPv4 to IPv6 is the small address space of the IPv4, right. So IPv6 will offer a huge address space, and therefore there will be no problem of address depletion in the future. Why? Because IPv6 address is using 128 bits. So 128 bits means that it is 4 times the address length of IPv4. So it is using 16 bits, 16 bytes, right. IPv4 uses 32 bits. This is using 128 bits. So the address length is going to be 4 times, right. And if we calculate, how many bytes are going to be there total, so it's going to be enormous, the number of addresses in IPv6 is going to be enormous, right. So if because now 128 bit address is going to be really huge and it cannot be handled by humans. So therefore different notations have been proposed to represent IPv6 addresses when they are going to be handled by the computer. So when it is being handled by the computer, definitely the 128 bit address format can be used, but when the same address is to be looked at by humans, then there are 2 notations which are being suggested. So the first notation is the binary notation, and the second notation is the colon hexadecimal notation. So in binary notation, of course, the address will be represented in the binary format, 0 and 1 format, which will be used for computers. In colon hexadecimal notation, the address will be basically divided into 8 sections, and each will be made of 4 hexadecimal digits separated by colons, right. Now what is hexadecimal digits? I am sure this will require some reading for those viewers who are not familiar with this, but to explain in very briefly, hexadecimal is a system, a number system which has got 16 digits. So instead of like in our normal number system, the decimal number system, we have 10 digits, 0 to 9. In hexadecimal we have 16 digits, so you have 0 to 9, and then you have alphabets of the English language A, B, C, D up to F. So F is equivalent to 15, right. So if this is an example, so this is a 128 bit address, of course this is not the all 128 bits, and then this is your colon hexadecimal representation. So the colon hexadecimal representation will be used when it is to be interpreted by the human beings. Binary will be used when it is to be interpreted by the computers, right. So as we know that the address space will be 2 raised to the power 128, because there are 128 bit address. So this address space, it will have 2 raised to the power 96 times the addresses which are given by the IPv4, right. So therefore there is no question of any address depletion to take place. In fact, it is said that only 2% of the addresses in the space will be assigned to people on the earth, and the other will be reserved for special purposes, because this is going to provide that many number of addresses, right. So if we assume that the number of people on earth will soon be more than 16 billion, right. So then also each person will have 288 addresses to use. So address depletion therefore is an impossible idea, especially in case of IPv6. Now in IPv6 basically there are three types of addresses which can be used, or basically the destination address can belong to any of the three categories. So the first category is the unicast, the second category is the anycast, and the third category is the multicast address. So the destination address, when you are specifying as unicast, it means that we are defining a single interface of a computer or a router. So the packet will be sent or routed to only one intended recipient, whoever's address is been given in the unicast address. In any cast address, basically a group of computers are defined which will share a single address. So any means any one of those computers can receive the packet. The packet can be delivered to any one member of the group, whichever is the most reachable, right. So any cast communication is used when you have several servers are installed to respond to any query. So whichever server, and all the servers, they will have a same address, same IPv6 address. So any server which is available can take the query and respond to it, right. So the request is sent to whichever is the closest, right. But the main thing to note here is that only one copy of the request will be generated and only one copy will be sent to the server, right. So there is in this there is no block, okay. It does not designate a block for any casting, and the addresses are assigned from a unicast block only. In case of multicast, basically it's very similar to what happens in any cast. The difference here between any cast and multicast is that in case of any cast, only one copy of the packet is sent to one of the members of the group. In case of multicast, each member of the group, so here also we are looking at a group of servers and each member will get a copy of the message, right. So there is a designated block for multicasting from which the same address is assigned to the members of the group, right. So there is no broadcasting here, and broadcasting is considered as another special case of multicasting, but basic important type of address in IPv6 is the anycast and the multicast. In anycast and the multicast, the difference is also very important to be noted here. Okay, so this was about IP addressing and the two versions of IP addressing. Now we move to the next segment of the lecture, in which we talk about the different data, and we will also be talking about the different transmission media and how the signal gets corrupted, or what are the impediments which the signal finds, right, and how actually the data is transmitted from one host to the other. So when we talk about data, basically data can be of two types, right. Data can be analog or it can be digital, right. So the term analog or the analog data, it refers to information which is continuous, okay, and digital data refers to information that has discrete stages, right. So very commonly we look at when we talk about analog and digital, we understand it in terms of clocks, right. Analog clock, it has got the hours, the minutes and the seconds hand, and it will give us information in a continuous form, right. So the movements of the hands are continuous in case of analog clock, whereas in case of digital clock, in digital clock it moves directly from one stage to the other. So it will it will move directly from say 805 to 806, right. So therefore the change is sudden, it is not continuous. So analog data such as the sound or basically all natural signals, all natural waves, they are analog waves, right. So analog data such as sound made by human voice, they take on a continuous value, and when somebody speaks, an analog wave is created in the air, right. Now this can be captured by a microphone and converted to an analog signal or sampled and converted into a digital signal, right. So basically the data, whichever the natural data which is flowing in the natural medium is analog, but then there are methods, there are ways through which this analog data can be converted into digital data and vice versa, and then we will use a corresponding signal to transmit that data also, right. So when we talk about a particular type of data, we also have to understand that in terms of transmitting that data, you will be requiring a corresponding signal, right. So we will be continuing our discussion on analog and digital signals in the forthcoming lectures. Till then, please keep watching CEC live lectures. Thank you.